Subscribe now.
Hello my dear children. Welcome back to the lecture series of aldehydes, ketones and carboxylic acid. We were doing the chemical properties of this chapter, and in the previous video I completed the nucleophilic addition of ammonia and its derivatives. Today we are going to start with the sixth chemical reaction, and that is haloform. It's a very important reaction. Let's get started. My name is 𝐒𝐿𝐵𝗲𝗏 and you are watching 𝐿𝐵𝗲 classes. So in haloform reaction we are taking aldehydes or ketones. The only criteria is we have to have a methyl aldehyde or methyl ketone. Means what? One of the R group has to be CH3. One of the R group has to be CH3. That means in one side at least you need to have COCH3. Okay? So this R group can be hydrogen. If this is hydrogen, this becomes aldehyde, acid aldehyde. This R group can be alkyl group, methyl, ethyl, propyl anion, or this R group can be aryl group. But one of the R group compulsorily has to be your methyl group. That means it has to be methyl ketone. COCH3 group has to be present. That's the only criteria for haloform reaction. This is sodium hypohalide. This is called as sodium hypohalide. Okay, which we are getting from NaOH plus X2. When we are mixing sodium hydroxide with halogen, we get sodium hypohalide. Now what happens is, break this bond from here, and this ONA, this particular part you just attach with this carbon. So what we get is, see how it is happening. We are getting RC double bond O, the ONA part got attached to it, and this X part gets attached to the methyl group, and we get CHX3, which is our haloform. CHX3, which is our haloform. Okay. So now, what is happening? See, here we have 3X, right? So for the balancing purpose, we'll put 3 over here. Okay, now there are 3 Na. One of the Na has gone there, so another 2 Na will be giving you a byproduct, that is NaOH. This is the entire reaction. So we are taking aldehyde or ketone. Only thing is that one of the R group has to be necessarily methyl group. Treating with sodium hypohalide, which is coming from NaOH and halogen, we are getting sodium salt of carboxylic acid. This is what? This is sodium salt of carboxylic acid. We are getting haloform and NaOH as a byproduct. Let's see. If your R group is H, here in this particular reaction R is equal to H. So your compounds becomes acetaldehyde. We have taken sodium hypochloride. This is called as sodium hypochloride, which has come from NaOH plus Cl2. Okay, what is happening? See, this bond has to be broken. So we get HC double bond O, ONA plus the Cl gets attached to the methyl group. So we get CHCl3 and we get 2 molecules of NaOH. For the balancing purpose, we need to put 3 over here. So this is your sodium formate. It is a sodium salt of formic acid, so that's called as sodium formate. CHCl3 is called as chloroform. So this is how we are getting chloroform from here. Okay. See the next example. Here the R group is CH3. This has to be necessarily methyl, as I told you. One of the R group, either this or this, anything, but it has to be necessarily methyl group. So this is called as acetone. CH3, COCH3 is your acetone. Here I have taken sodium hypoiodide, which is formed by the reaction of sodium hydroxide and iodine. So here iodoform will be formed. This is CH3, C double bond O, O Na. Okay, just break this bond and attach this ONA part with it. So CH3COONA. The haloform here is iodoform, that is CHI3, and the byproduct is NaOH. I'll put 3 over here for balancing purpose, so this will be 2. So what are the products we get? We get sodium acetate. This is sodium salt of acetic acid, which is your sodium acetate, and we get iodoform. Iodoform is a yellow colored liquid. Okay, come here. Here my R group is pH group or aromatic group. Okay, so this is called as acetophenone. Acetophenone. NaOBr is your sodium hypobromide, which is formed by the reaction of sodium hydroxide and bromine. So break this bond and attach the ONA with the carbonyl group, so you get COONA, plus we get bromoform, that is CHBr3, plus the byproduct is NaOH. Let's balance it. 3Br this side, so I put 3 over here and 2 NaOH over here. This is what is a sodium salt of benzoic acid. So we call it as sodium benzoate, and this is bromoform. Okay, so this is our haloform reaction. The next reaction, that's the 7th reaction, is aldol condensation reaction. Again, this is very, very important. See what is the write-up. It's saying that aldehydes containing at least one alpha hydrogen atom. I'll explain you what is an alpha hydrogen atom. So aldehydes containing at least one alpha hydrogen atom undergo a reaction in presence of dilute alkali. So that alkali could be NaOH, KOH, or Na2CO3, which acts as a catalyst basically, and it forms a beta-hydroxyaldehyde, which in common is called as aldol. And this particular reaction is known as aldol condensation. Now what is it? I'll just let you know. What is an alpha hydrogen? Suppose if I take an aldehyde, HC double bond OH, this is an aldehyde, right? This is my functional group. If this is the functional group, the adjacent carbon, okay, to the functional group is called as alpha carbon, and the hydrogen attached to the alpha carbon is called as alpha hydrogen. For example, if I have functional group CHO like this, and this side I am having another carbon, and these are the 3 hydrogen attached to it. You know that this is called as acetaldehyde. This is an aldehyde of 2 carbon, which is called as acetaldehyde, and the common name of this aldehyde is formaldehyde. Okay. Now here you can see this is the functional group. This is the functional group, and this carbon is adjacent to the functional group, which is called as alpha carbon, and the hydrogen which are attached to the alpha carbon are called as alpha hydrogen. So in this particular molecule, there are 3 alpha hydrogen present. Wherever in this molecule you can see there is no alpha carbon, and hence there is no alpha carbon, and hence there is no alpha hydrogen. So for aldol condensation, the main criteria is you have to have alpha hydrogen. That means this molecule will not show any aldol condensation, whereas this will show aldol condensation. First of all, you need to understand this. Okay. Now, what is this aldol condensation? What happens is, if you have an aldehyde or ketone having alpha hydrogen, so suppose I am taking CH3CHO. This is an aldehyde having alpha hydrogen. Okay. So 2 molecules of this aldehyde will condense together in presence of dilute alkali. Now this dilute alkali can be NaOH, KOH, or Na2CO3. In presence of this alkali, they will condense together to give you a beta-hydroxyaldehyde. Now what is a beta-hydroxyaldehyde? So here we will be getting, so basically what happens here, I'll just show you this. Suppose this is the open structure of one aldehyde, C double bond OH. This is one molecule, and I am writing another molecule like this. The alpha hydrogen I am showing like this, C double bond OH. So what happens is, one of the alpha hydrogen gets attached to the oxygen. This is the shortcut I am showing, and this carbon gets attached to this carbon. Okay. I'll just show this hydrogen down so that it becomes easy for you to understand. Okay, and this arrow I'll be showing you like this. This carbon gets attached to this carbon. So what is the product you see? First I am writing this part, C, H, H and H. There is no, nothing happens here. Now this carbon, so this carbon, oxygen gets attached to hydrogen, so the double bond will reduce to single bond. This hydrogen is as it is, and carbon there is a bond. So carbon, these are the two hydrogen attached to this carbon, and then we have C double bond OH. This is the product. Now what is it? See, this is my functional group, this is my alpha carbon, this is my beta carbon. So in the beta carbon there is a hydroxy group. So this is called as beta hydroxy and the aldehyde. It is a aldehyde. So it is beta hydroxy aldehyde. This is a product which in short or in common called as aldol. Why aldol? Because aldehydes for aldehyde, aldol, for aldehyde we write al. So this is for aldehyde and this is for alcohol. So you know that hydroxy group is also called as alcohol. So this compound in common is called as aldol. Okay. Now this reaction doesn't stop here. What happens is further, if you heat this molecule, minus water molecule takes place. That is, water molecule is eliminated. How? This this OH group and this hydrogen, they get eliminated as water molecule. Since here there is a elimination, carbon-carbon double bonded compound is formed. So the compound which is formed after the elimination of water molecule is, I am writing down this in condensed form. So this is CH3, then you have a CH, this CH, then you have a double bond CH, so double bond CH, and then you have again C double bond OH, that is aldehyde group. This compound is called as alpha beta unsaturated compound. Why alpha beta unsaturated? Again, see, this is your functional group, this is your alpha carbon and this is your beta carbon. There is an unsaturation in between alpha carbon and beta carbon, so this is called as alpha beta unsaturated aldehyde. Okay, the functional group is aldehyde, so it is alpha beta unsaturated aldehyde. Okay, so this entire reaction is known as aldol reaction. So what is happening initially? There is an addition. You can see these two molecules get added. So initially there is an addition followed by elimination of water molecule. So therefore it is a nucleophilic addition elimination reaction. So say the next point is, formation of aldol is an addition reaction. As I mentioned, the first step is addition. Aldol formed from aldehyde having alpha hydrogens undergo subsequent elimination of water, okay, molecule on warming, giving rise to alpha beta unsaturated aldehyde, which I told you. So again the same reaction here. You can now see in short or in one step how do we write. This is acetaldehyde. Okay, I should write it acetaldehyde. This is acetaldehyde, the first molecule say, and this is the next molecule of acetaldehyde in presence of dilute NaOH. Now what is happening? The hydrogen gets attached over here, this hydrogen, the alpha hydrogen gets attached over here, and this carbon gets attached over here. So the product we get is, I am writing this CH3 as it is, then this C, hydrogen gets attached to oxygen, so it reduces to a single bond. This hydrogen is here, there is a bond between this carbon and this carbon. Now this carbon has two hydrogens, so I am writing CH2 and then C double bond OH. This is your beta hydroxy aldehyde, okay. So we will write beta hydroxy, the particular name is beta hydroxy butyraldehyde. Why? Because there are 4 carbon atoms altogether. If you see 1, 2, 3 and 4. So it's called as beta hydroxy butyraldehyde. Okay, now this will be followed by warming, so I will write this hydrogen over here. This will be followed by warming, which will give rise to elimination of water molecule. So if you warm it, you get CH3, CH, double bond CH, C double bond OH. This is alpha beta unsaturated aldehyde, and this particular aldehyde is called as protonaldehyde. Protonaldehyde. This is the common name of this particular aldehyde. It is protonaldehyde. Okay. Next example I have taken ketone. So I'll just show you in the next page ketone. Okay. So this is my one molecule of ketone, CH3COCH3, and this is another molecule of ketone where I am showing the alpha hydrogen like this, CH3, C double bond OCH3. The condensation happens in presence of alkali, and here in this particular case we take barium hydroxide or baryta as the alkali. Okay, so this hydrogen, which is your alpha hydrogen, gets attached to this, and this carbon gets attached to this. Okay, so what is the product we get is CH3COH. I'm writing this CH3 down, and then there is a carbon-carbon bond. So this carbon having two hydrogen, I'm writing one hydrogen like this, and then C double bond OCH. Now if you see this, this is a beta hydroxy ketone product. Okay, beta hydroxy ketone. This is the general name is beta hydroxy ketone, and it is 1, 2, 3 and 4. So it is 3 hydroxy. The IUPAC name I am writing now. 3 hydroxy butane 2-one. This is a particular name. Now when you heat this, water molecule is eliminated, H and OH. So you get CH3C. There is a CH3 down. There is a double bond CH, C double bond O, CH3. So this is alpha beta unsaturated because this is a functional group. Okay, this is a functional group. The adjacent carbon is alpha carbon. This is beta carbon. So this is a alpha beta unsaturated ketone. So you get alpha beta unsaturated ketone. And then you can write down the IUPAC name. It is 1, 2 and 3. So and altogether 1, 2, 3, 4 and 5. And this is 1, 2, 3 and 4. So 4-methyl, okay, and then 1, 2, 3, 4 and 5 pentane, pent, 1, 2, 3, 3 in and 2 on. Okay, this is the IUPAC name. The common name is methyl oxide. This is called as methyl. So as I mentioned that aldol condensation is a nucleophilic addition elimination reaction. So you have seen that the first step is the addition and the second step followed by water molecule elimination. Now next is cross aldol condensation. Okay, so cross aldol condensation refers to the aldol condensation that takes place in between two different aldehydes or two different ketones, or maybe one aldehyde and one ketone. The only criteria is they should have alpha hydrogen atom. So we get 4 different products basically. Okay? So we will see one example. Let's take the example of ethanol and propanol. So taking the example of ethanol, CH3 C double bond OH. This is ethanol and propanol, CH3 CH2 C double bond OH. This is propanol. So what happens is there are 2 products which are self-aldol product and there are 2 products which are crossed aldol product. So what happens, see, first I'll be writing the self-aldol product, but this will get condensed with itself and the product is CH3 C OH H CH2 CHO. This already I explained you followed by water elimination. So this is your beta hydroxyaldehyde, but this is getting self condensation. This molecule is doing self condensation. Similarly, this molecule can do self condensation. So the product we get is CH3 CH2 COH, and now this will be CH2 CH3 C≡OH. This is a self-condensed product of propanol. Okay, so if you do this, you will understand. Now the crossed product. This is self product. This is self condensation, and this is also self condensation. Now the cross product, where this molecule is getting attached to this. This is acting as a nucleophile and getting attached to this. So what will be the product? CH3 COH H CH CH3 C≡OH. This is a crossed aldol condensation, and the last product will be, but this molecule will get attached to this, means this will be acting as a nucleophile. So there it will be CH3 CH2 COH H CH2 CH2. This is a cross product. So this is a cross product, this one, and even this is a cross product. So in case of cross aldol condensation, where we are taking two different aldehydes or two different ketones having alpha hydrogen atom, or one aldehyde and one ketone, we are getting four products. Two products which are self-condensation product. This is getting condensed with this, giving you this. This is getting condensed with this itself, giving you this. And two are cross product, where once this will be acting as a nucleophile and will get attached to this, and in the second case, this will be acting as a nucleophile and will get attached to this. So we are getting four different products. Okay. So today we have completed with two important reactions, haloform and aldol condensation. Both the reactions are very important. So do it nicely. In the next video, we are going to start with Candice-Arrow reaction. Thank you so much. Stay updated. If you feel these videos are beneficial to you, please subscribe the channel and press the like button. So taking the example of ethanol, CH3 C≡OH. This is ethanol and propanol, CH3 CH2 C≡OH. This is propanol. So what happens is, there are two products which are self-aldol product, and there are two products which are crossed aldol product. So what happens, see, first I'll be writing the self-aldol product, but this will get condensed with itself, and the product is CH3 COH H CH2 CHO. This already I explained you, followed by water elimination. So this is your beta hydroxyaldehyde, but this is getting self condensation. This molecule is doing self condensation. Similarly, this molecule can do self condensation. So the product we get is CH3 CH2 COH H, and now this will be CH2 CH3 C≡OH. This is a self-condensed product of propanol. Okay, so if you do this, you will understand. Now the crossed product. This is self product. This is self condensation, and this is also self condensation. Now the cross product, where this molecule is getting attached to this. This is acting as a nucleophile and getting attached to this. So what will be the product? CH3 COH H CH CH3 C≡OH. This is a crossed aldol condensation, and the last product will be, but this molecule will get attached to this, means this will be acting as a nucleophile. So there it will be CH3 CH2 COH H CH2 CHO. this is the cross product. So this is a cross product, this one, and even this is a cross product. So in case of cross aldol condensation, where we are taking two different aldehydes or two different ketones having alpha hydrogen atom, or one aldehyde and one ketone, we are getting four products. Two products which are self-condensation product. This is getting condensed with this, giving you this. This is getting condensed with this itself, giving you this. And two are cross product, where once this will be acting as a nucleophile and will get attached to this, and in the second case this will be acting as a nucleophile and will get attached to this. So we are getting four different products. Okay. So today we have completed with two important reactions, haloform and aldol condensation. Both the reactions are very important. So do it nicely. In the next video we are going to start with Cannizzaro reaction. Thank you so much. Stay updated. If you feel these videos are beneficial to you, please subscribe the channel and press the like button.